Hey everyone, we're going to find the Maclaurin series for f of s and find the associated radius of convergence for f of x. We're going to use the definition of the Maclaurin series. So I'll write that out. That's going to be, we want r1 minus x to the power of negative 2 to equal f of 0 plus f prime of 0 x plus f double prime of 0 divided by 2 factorial, and then we have x squared, and so on. All right, so the next one would be, let's do the next one, triple prime of 0 divided by 3 factorial, x cubed, and so forth. And this is your formula here. So what we're going to do is, for this first piece, we're going to write f. This is when n is 0. We have f of 0. Now that's going to equal 1 minus x to the power of negative 2. And we're evaluating that at x equals 0. And that's going to equal 1. All right, so now when n equals 1, we're going to get f prime of 0. So that's the first derivative. And that's going to give you 2 times 1 minus x to the power of negative 3. Evaluate that at x equals 0. And that's going to give you 2. All right, the next one, let's try when n is 2. So we have f double prime of 0. That's going to equal 6 times 1 minus x to the power of negative 4. When you evaluate that at x equals 0, we're going to get 6. And let's try one more. So when n equals 3, we have f triple prime of 0. That's going to give me 24 times 1 minus x to the power of negative 5. And then you evaluate that x equals 0, we're going to get 24. And then finally, if you want to do one more, we can do n equals 4. So that's fourth derivative at 0. That's going to give you 120 times 1 minus x to the power of negative 6 at x equals 0. That just gives you 120. So filling this out right here, this is just basically what we're doing is we're dividing by 1 for this, and then we'll be dividing by 2 and so forth. So let's do that part. And we're going to get this equals 1 plus 2x plus 6 divided by 2x squared plus 24 divided by, now 3 factorial is 6, so I'll just write 6x cubed plus 120 divided by 24 x times x to the 4th power plus and so on. All right, so simplifying this, we're going to get 1 plus 2x plus 3x squared plus 4x cubed plus 5x to the 4th, and then plus, using our formula, this is going to equal the sum. So n equals 0 to infinity. And looking at the formula, basically we have n plus 1 times x to the nth power. So basically, when you plug this in, this is 1 higher. So if you're looking at your x to the n, then the coefficient is 1 more. Now we're going to do the test for convergence. And so we're going to go ahead and use the limit test. And write this as the limit as n approaches infinity. And we have a sub n plus 1 divided by a sub n, absolute value. So that's going to give you the limit. as n approaches infinity of n plus 1. Now, remember, this is just 1 divided by 1 minus x squared. So this is going to be n plus 2, and then we're going to have x to the power of n plus 1. And then for the denominator, you're just copying down this part. So that's going to be n plus 1 times to the power of x to the power of n. So basically what I was taking is looking at this one. And that was our sum. So looking at that, that's what I use for my limit. Now simplifying this, we look at this. This is just going to end up being absolute value of x, because this is x times x to the nth divided by x to the nth. So we're just left with the x. So we're going to have absolute value of x times the limit as n approaches infinity of n plus 2 divided by n plus 1. Now that's going to equal absolute value of x. The limit of this is just 1. So we get absolute value of x is less than 1 if we want it for convergence. So the radius of convergence equals 1. Thank you. Have a nice day. Bye-bye.